Howdy, this is James Prey, and I'm going to be talking about SketchUp for 3D printing, specifically designing for 3D printing, at the request of a friend who was interested in how I do this. So I am going to be working on this design and just sort of talking over it. I'm not going to be doing a sort of a easy demonstration model. There's plenty of tutorials out there for that, so hopefully I'll be focusing on sort of my value add to this conversation, which is going to be sort of a combination of how to get started, how to use it easily, and then just what I do to make the designs I do. So SketchUp is I really like SketchUp. I've been using it for quite a while. It's pros for SketchUp. I think it's very accessible. It's easy to pick up compared to a lot of programs I have tried. The interface I think is very clear. Just how you get around parts. It's very visual. It made a lot of sense for me as somebody who is coming primarily from, say, 2D design in Photoshop. There's a lot of tutorials out there for beginners, which is nice. There's a lot of add-ins. So con-wise, there are certainly cons. I would say that this is not really a true, it's not a true CAD program. It's not, I don't think that there are professionals out there really who are using SketchUp seriously to design like parts for machining. They have not done in like free versions that you can install since 2017. I think another con is that the sort of the mesh you see is the mesh you get. It's not like parametric, where you can say I want it to be this exact shape and then render it at a certain polygon resolution for output, which I think could be a pro or a con. It's not great at complex curves or sculpting. There are much better tools for that. When you want to chamfer or fillet complex shapes, that's not all that easy. If you're trying to fillet something or chamfer it, and it's it's not like all in one plane, you're gonna have to get creative with that. I think complexity-wise, this will only take you so far. It might not fit into more complex development pipelines if you had to work with other people. It's not great if you want to import or edit STLs. But all that said, I think the only beef I have with it that does get annoying to me is that as your models or environments get more complex or big, they can get sort of weird resolution issues where things are not exactly a set number of units. Like points are not. It's just strange. It's like the geometry stops really fitting together neatly, like planes that should be parallel. It's like SketchUp thinks they're maybe just a little bit off, and they sort of stop fitting together. Anyway, you have to have a lot of stuff in a project for that to start being an issue. And if you work clean from the beginning, it's not such a Anyway, so let's get into it. So if you want to use SketchUp for designing stuff for 3D printing, the two extensions that you really need to have, first off, I think it's like Cleanup 3. You can get this add-in online. It's really good at clearing out geometry that's bad, basically cleaning up models so that you can get a clean export for printing, which is important for slicers to be able to interpret stuff. And the other one is an STL exporter. I'm not exactly sure what it's called, but Googling that would get it for you. And that gives you this option in the file menu to export as an STL whatever you have selected. So let's get into it a little bit. If you want to have a good time in SketchUp, it's really a mouse and hotkeys situation. basic camera maneuvering if you want to get around quickly. There's the hand tool, which is H, which you actually use the H hotkey to drag things, or drag your view around. Spacebar gets you the selection tool. What I like to do to get around is, so middle click on the mouse gives you orbit, and if you middle click and hold shift, that turns it into a hand. So you can, and the mouse wheel is zoom in and out. So by switching between those, you can move around your model, get different views, go in and out, and so that makes it really easy to get around your work. So that's kind of muscle memory that gets built in with a little bit of practice. Um, I I won't get into like a rundown on all the tools. There's lots of tutorials out there for that. Um, but the stuff that I use a lot, the selection tool is really important. Um, something that's useful to know for the selection tool is that the selection behavior is different if you drag left versus dragging right. If you drag in this direction, it will only grab what you select completely. So you can see I didn't select that entire last screw there, and it didn't get selected. Um, Whereas if you drag this direction from right to left, it will select anything that you have touched with the selection box. Um, so that can be, so right now all of these objects are components, so it's grabbing them as units. But when you get into a model, so they're like dragging the selection box, it's grabbing these lines that were in there and any planes that were fully in there. Whereas if I drag the other way, it's going to grab the entire planes that happen to be touching there. So you can see that has grabbed all of this geometry that was anywhere in there, as long as it's like a contiguous plane. Okay. Also useful to know about selection, when you one click will select whatever is under your cursor. Double click will select that and anything touching it, so that's good if you want to get a plane and all the outline stuff. Now say you just want the periphery of an object, then you can hold shift, which gives you the plus minus, and if you click anything you click that's selected becomes unselected. So now I have deselected that plane, which can be useful in situations where you want to clear out some outline or stuff that's stuck to a plane. Now, so that's double click. If you triple click, it's going to select all the geometry that is connected to whatever you just clicked. So if you want to, say, clear out like loose stuff that's not, it's like junk geometry, one thing you can do is select all that geometry with like selection or Control A, and then go to that and triple click to click it all off. And what that would leave you with is any geometry that is not connected to this, which generally you don't want floating around. The only case when you would is if there were like holes inside cavities. Okay. SketchUp also makes it really easy to like snap to different things. Show you that in a second. The tape measure is really important at SketchUp. So with the tape measure, you can get a distance off a point like that. You can also get a distance off a line, and this is very useful. So the axes you can see are red, blue, green. Whenever you are moving, along them, the arrow is or the line, whatever, you're going to see that color corresponding to that. And so, turn on guide view. So, using the tape measure to, say, extend lines is incredibly useful. If you say, well, I want to carry sort of a hexagon rhythm around my design, which I do here. If you've got a handy hexagon or some angle, you can use this to quickly reproduce that angle somewhere else, or always remembering that a triangle is going to make a plane, and any two lines that are on a plane, anything that you draw along them and connect is going to make a plane as well. So that can be useful. Okay. Yeah, so like quick drawing stuff, if you are using like the line tool, you can, so there are different snaps that you can get by going to different parts of your model. So the midpoint of a line is going to give you a snap. So this is the edge of a hexagon that was created as a six-sided circle. So this outline SketchUp treats as sort of a unit. You can snap to the midpoints of lines. It could be very useful for cutting things in half or whatever. But if you go to any corner of something that was created as a circle, it will show you, there's the center of that, and you can snap to it like that. And then also, if you mouse over something, like mouse over a line, mouse over something like this. So right now it's turning pink when I am making a line that is parallel to this edge. And if I sweep it around like that, it'll also turn pink or magenta when I am perpendicular. So that's handy. So the arc tool, I use the A hotkey for that. When you are drawing an arc from one line to another, it'll turn light blue like this if it's like a perfectly smooth curve off of that, and it'll turn pink if it's a perfect transition from one line to another. So you can get into that mode off of any edge. You can also get into it off of intersections, say with a tape measure item. So like there, you can see that is giving me the arc thing. But if you go off of a point, well, it's going to give that to me because it's being contrary. But you don't. If it's not going to sort of show you those training wheels, then you're just going to get a dotted line until you pick the second end of your arc. Okay. Yeah. So another important tool I want to talk about quick. There's lines, circles, rectangles. I mostly use the line tool, push pull, and circles for modeling. I actually don't use the rectangle tool that often because it's a lot easier for me to start from the center of things and work outward than it is so you have to create a rectangle from like edge to edge, and they're not always real cooperative about being in the plane you want. So I most often work by creating a plane and then modeling on it because it'll snap there. So as far as the eraser goes, one big mistake I made starting out was that I always used the eraser to get rid of geometry without selecting things first. And the trouble with that is that when you're just using the eraser on stuff, if you are not careful, you can erase geometry that's like behind. It's like clicking here is going to erase anything under there. So you could erase. If you're just going do, you can like unintentionally clear out geometry, like in the back of your model. Like that's not. So let's say I want to get rid of that now. And if you don't notice that you've made a problem like that, it's going to give you heartburn down the line. So the eraser is useful for more than just actually deleting. So as far as deleting things go, I prefer to select things and use the actual like delete key. Of course, that's kind of easier for me because I have a delete hotkey on the keyboard I use that's like right in left-hand pinky range. But just something to be aware of in general. But so the eraser, what I use the eraser for most often is managing which lines are displaying and non-displaying. So in SketchUp, there's basically hard lines like this, but there's also soft lines like these. And what I'm doing here is I am using a hotkey that toggles on the display of hidden lines. And so, or hidden lines are basically like smoothed lines. That's how SketchUp displays them. When you're printing stuff, there's no distinction. Like there isn't. It doesn't like try to print a soft line like this any differently. But sort of for the sake of managing visual clutter, you can like soften lines that need to be there, but that make it hard to read your model. So the control for that is to if you hold Control and go over a softened line, that's going to soften it. So I just did this, and you can see that line's still there, but now it's like a smooth thing. And you can see I've got most of the curves around here smoothed. This is not, sometimes, especially when you're using the cleanup tool will kind of meddle with what lines are smooth and what aren't, depending on your settings. Something to watch out for. But you can kind of use that too. Or if you need to manage, like say, you just want a certain plane. Worth noting that if you are showing hidden geometry, then the selection works differently. Like if you've got hidden geometry hidden, then clicking here you can see that selects all of this. Whereas if I have it displayed, then clicking here only selects up to those dotted lines. So, okay, what else? So some important manipulation tools that I get a lot of use out of are the move and rotate tools. So move is M, and you can grab any any piece of geometry and scooch it around. It'll try generally to snap to the axes. It's a good idea so any operation you do in SketchUp, you can, like once you've got it into the kind of get going mode, you can type a measurement and have it go that far. And that is you don't want to, if you can help it, just like move geometry around with the mouse and leave it there, because it's going to be some weird not round number of units, and it's just a lot easier to work in whole units when you can help it. So move can, beyond just moving things around, you can also, if you hit Control, that puts it into sort of what's called multiply mode. So let's say I want to, so I just hit Control and now I'm moving a copy around. So I just said move that 4,000 to one side, and then if you want to have, say, more copies, you can also, after you've entered your length, you can use the slash and enter a quantity, and it will, so that's /2, /3, /4, that's one way to get a lot of copies of something. Generally, if you're copying geometry and it's like whole items, it's better to make components. I'll talk about that in a little bit. But if you've got some part of your design that's going to be exactly the same all over, it's a smart idea to actually make that a subcomponent, so that which I have done on this. So this design is it's a kind of my own homebrew copy of what Nimble calls a speed block. So it's an overdrive. So it's driving the output shaft 3 times for every revolution of this stepper motor, just because the gear drive, the gear reduction on the Nimble is so high. And so I am updating this design here to just because I didn't think this looked that great, and I'm also updating it for different bearings. And you can see I realized I needed like a retraction spring on the idling, on the tension adjustment, and there was there's no anchor for that, so I'm adding an anchor right there, and so on. So that's what this is going to be. And so one example of multiplying a piece of common geometry across a design is in these bearing sockets. Um, because I am switching to different sort of bearings, I set, and so there's there's three different places these bearings will be, and so instead of needing to fine-tune this socket for every place in the model where they are, I made that socket into just a hexagonal plug, and so that fits into the design in these three places. And not only does that mean that I can fine-tune one place and it's updated across the model, it also means that I can print out this socket by itself to make sure I've got the fit correct. And so I've been actually working on fine-tuning that lately. So I want to come back to that when I start talking about sort of considerations for designing for 3D printing. Yeah, so apart from moving, there's also rotating. You can rotate stuff. That's the Q hotkey. So you choose a grip, you choose an anchor, and then you can decide how far you're going to rotate it. Again, a good idea to sort of type in or make sure that it's snapping to whole units instead of rotating willy-nilly. You can use the rotate command also to multiply stuff if you want, and it works sort of the same way. You type your angle and then you type a slash and how many you want, how many extra you want. So that's a /2, and it's made 2 copies, rotated around that center. When you have components, there's also another way to rotate things. So if you mouse over a component with the move tool active, then you'll get these grips on the faces, these little red. So if you select any of those, it's actually going to give you like the ability to rotate like about that face. But it's a little different when you rotate components this way, because instead of like the degrees that it rotates won't be a delta from where it's at now, but it's actually like absolute. So like wherever it's at now, so like if I just click here and say I want to rotate it, like the starting value right now is actually 90. So you probably can't read the angle thing, so that's actually like the 0 value. So just something to be aware of. You can still rotate components with the rotate tool instead. Okay, and the kind of the last big like manipulation tool I use a lot is the scale tool, which is S, and that's going to, anything you've got selected, it's going to put a grid around. That's really hard to see, isn't it? In something else. Okay, so there I've got, or select that perimeter. So it'll put these grips around it. If it's three-dimensional, you'll get this kind of grip box. And it works about like you'd expect for a transform tool. But one other useful thing you can do with it, besides just scaling things, is that this can be used for mirroring objects. Just not going to be very clear from that, but say you want 2 objects that are going to be back to back or mirrored. A very important, getting back to that like idea of multiplying design components that are all going to be the same. If you're going to have a design that will be perfectly symmetrical, you can break it in half and then just mirror half, and the way like mirror a copy of it, and so then anything you do here will happen over here as well. So I can save some time. Okay. Yeah. So then there's sort of more situational tools. There's the offset tool. That's F. So that lets you pick something, and pick some perimeter or edge, and you can create another edge that's you know, however far away from it. That can be pretty handy for so two ways that you can say, let's say you want to make a chamfer around a circle like this. One way, my preferred way, is, so I've selected that, I'm going to move it, a copy of it, that inner edge. I'll move that down, and then I will scale. I'll grab the original and scale it outward, and there, now we've got a chamfer. Option 2 would be to make an offset out here and then move this inner one down. It's a little bit easier to get a precisely sized chamfer this way. You know, because you can say I want an offset of 100, and I'll move this center down by 100. Although if you're ever having trouble getting it to snap to a direction, you can just create a quick tape measure line. Like this is not really wanting to move down for me. Actually, it looks like I've yeah. Okay. And so when you are moving geometry that is connected to other geometry, there are kind of two modes to it. There's autofold and not autofold, and you toggle that on with Alt. Usually they kind of turn out the same, but it can turn out differently when it's not sort of straightforward geometry like nested circles like this. Sometimes SketchUp will really guess wrong about where to draw connecting lines for the new geometry. So sometimes you have to just get in there, erase whatever it did, and then quick. So don't be afraid to get in, to delete geometry and then just use the line tool to recreate it. You can see that's sometimes that's just it's hard for SketchUp to figure out. So that's two ways of doing a fillet, kind of in my in order of preference. And so there's also the follow me tool, which will take a shape of your choosing and run it around a perimeter. That's also how you do vase mode. That's if I can get away with simpler methods of doing it, I usually do that. But if it's a more complicated perimeter, sometimes the follow me tool is the only way to do it. So you can see I just drew a line. I'm just going by hundreds, perpendicular to there, and so right now I'm going to connect end to end inside this geometry. So there's my triangle for the chamfer, and then I'll choose the follow me tool and select this plane, and then so this can be a little touchy, take some practice. You sort of run it around the perimeter. Sometimes you actually kind of have to nurse it around. But so there's another way. Well, that was what I did, for example, to create this complicated slope face. Which, still need to make some adjustments there. That's pretty handy. And then don't forget about the note tool. So as I'm working on a design, I like to use that to remind myself to fix things. And the text tool, that's looks like this. So when you use that, it's actually gonna make the text in a component. I'll talk about the component stuff in a minute. So right now you can. So when you double click it to open it, the geometry is inside. So then you can, if you want text on your models, usually what I do is I save this for last, and then I will get in here. Then I will explode the component to get myself the geometry. then stick it to the plane. So, tip for fixing SketchUp weirdness: if it's sometimes you'll see when you like stick stuff together, it'll make a hole where you still wanted a plane. All you need to do is draw a line. You can draw a line across it, or you can actually just trace part of the outline, and that'll encourage SketchUp to stick it back together. So there, if I wanted my design to say, "Hey you," I'm using the push tool to just intrude these a little bit. Is that the opposite of extrude? Um, and when you're using the push-pull tool, you can snap that to any other part of the model to get it that far. I would probably just play with the push-pull tool. It's got its own eccentricities. But if you're doing a bunch of things in a row like this, you just snap each one in succession to the bottom of the next one. I don't actually want that right now, so we'll get rid of it. Okay. Okay. So I think one of the most important parts of my design workflow is working in components. You really don't want just, if you can help it, you don't want geometry just floating around out in the main workspace, because it's vulnerable. I feel like it's not kind of segregated from the rest of the model, and especially when so you have to work in components. Like you have to, like, I don't know if you could get away with exporting something that was to STL that wasn't a component. But anyway, so the hotkey for making something into a component is G, and let's see if there's, so break my own rule and use the rectangle tool. So any geometry you select, you hit G, it'll go to the create component. Okay, hit G and go, and then now this is a component. In order to edit it, you actually have to double click it to open it. And so that way you can have different parts that are all together, but you can work on them separately without having to worry about like that eraser thing I mentioned, or like say you're like, you could get into a lot of trouble with raw geometry if you were just using the selection box, grabbing things, moving them around. You could mess up some part of your model by accident that you weren't looking at. Not so good. So that is how I like to work. And you can put components inside components. So like this whole thing with these vitamin models that I made for spacers and idlers and bearings and so on, like that's all one unit. If I double click in there, now we've got the vitamins separated out, and we've got these smaller assemblies, so I can sort of keep drilling down as deep as I need to go. Something important to note is that anything, so you can have components that are separate, as these are. You can also have components that are actually intended to be printed as all part of the same unit, and if you're going to do that, it's very, very important that that those parts are perfectly flush to each other. And the way you can tell that in SketchUp, I run inside this geometry, if you have a plane and like two planes from two different parts that are perfectly next to each other, perfectly coplanar, then you will get this weird kind of strobe effect. If you have that, then your parts should play well together. Like you should be able to turn them into one solid part before you export. If you don't, if you're not really careful about that, then when you go to turn them into one solid part and export them, you're going to get all kinds of like weird geometry at the interface. You'll have to do hand cleanup. It's no fun. So Um, yeah, be careful about that. um, oh, and I guess probably the most important advanced tool in my toolbox, something that will let you start to break away from just extruded shapes, and it took me a long time to find this, is the intersection tool, which is not really a tool itself, but rather it's an option you get when you select something that you've got selected. So right now, I'll demonstrate how this works. So the Pro version of SketchUp has like union tools. This is you have to pay for it, or I mean it's only in the Pro SketchUp, but intersection is sort of the next best thing, and it's really powerful. So if I do this, SketchUp is not going to treat these two bodies as one unit. There's still geometry inside these two. So if you were to I'll show you. So this, if I select it and look at the entity info, this is a component. It is, what you want if you want to export something for printing, it's got to be a solid component, which means that it is basically that there's no extraneous faces or lines in there. It is only and exactly the geometry that needs to be there to describe a solid, say, watertight shape. It would hold water, and there's nothing extra in there. So right now this is not a solid shape, and so one way you could solid this up manually would be to take your line tool and trace all the way around. You can see that you get like this little intersection snap. You could trace, 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 and then go inside and remove this internal geometry. But a way to do this very quickly, and it can save a lot of time if the geometry is complex. Like say, if I need to do more complex curved surfaces, this is how I do it. I'll make the curved objects separately and then slide them together. Say I want to carve something off, and then when you right click, you go to intersect faces with selection, and now you can see that SketchUp has nicely traced all the way around there for us. Now this is still not a solid component because that only traced the edges. We got to get rid of this internal geometry, so we had sort of all the leftovers. And you can see I'm sort of maneuvering freely around the inside of these. It's because I've got a lot of practice. But so if I did that right, now you can see this has changed to a solid component because there is there's no extraneous geometry inside there. Something else to know when you're making objects for export to STL, you need to pay attention to the face orientation. So if I just delete the top off this quick, you'll see that SketchUp is, so the outside by default is white, the inside is this sort of gray-blue. So this is an outside face and an inside face. And you need to be sure that all your outsides face outside and all your insides face inside. Otherwise it can cause slicing problems. And so the way that can happen, if you do certain push-pull operations, like you do a push-pull but you use the control command that makes it make a second, basically leave what you started with and start a new one, oftentimes you'll find that will make it's not going to cooperate, but it often ends up making those reversed faces. And so what you need to do is select whatever geometry is reversed and use the reverse faces option. So what do you do if your model is painted? So the white outside, dark inside doesn't necessarily display if you've used the paint bucket to paint parts. What you can do is so under the view options, there's the face style options, and so they're shaded with textures, and there's monochrome. I have those hotkeyed to N and V, so so if I hit V, that'll take me into monochrome version, and that will always use that inside-outside shading. So one thing you can toggle. I also have the show and hide hidden geometry hotkey, good hotkey to get to know. Um, Component edit, more useful hotkeys. You can see that so the rest of the model disappeared when I went in here. That's because I'm in the view mode for component edit that hides the rest of the model. So if I've got that hotkey to J. If I hit J, now I can see the rest of it. It's grayed out, but that's good to be able to kind of quickly toggle in and out of. Like, this part is kind of buried in there. So if I want to work on it, and then say check the fit, how does this fit in there? It's a good hotkey to have. Another good hotkey for component edits is hide similar models. So right now I've got the rest of the model hidden, but any copies of this component in particular will show up. Sometimes you want that. I've got toggling that on and off to Shift J. So that's a pretty handy hotkey. So let's talk design considerations, designing for 3D printing. So when I'm designing parts like this, I don't always do it right away, but eventually I sort of create like a printing zone where I set aside copies of the parts oriented like they will be for printing. So even though they're stuck together over here in the actual working design, they'll print with these faces down. And I've still got a ways to go. This design is in midway there, but there are things here that would not print very cleanly. Like I'm probably going to change the whole shape of this, but right now that would require supports to print. This skinny little overhang right there would probably not print very neatly. And so this lets me kind of check for factors that, of course, the final check is to export it to STL and then see how it slices. But this way I can sort of do that preliminary check to see, okay, what am I going to need to do to make sure this is a design that is going to be readily printable with minimal if we got to use supports, to make sure that they'll be easy to remove and kind of minimize the supports that'll be necessary. Another design consideration is polycount. So every time you select the circle or the arc tool, down here it's going to give you a sides quantity. So you can model with circles that have hundreds of sides and arcs that have hundreds of segments, but not only does that produce tons of geometry, at some point it doesn't really it can make for really complicated geometry that's takes a lot of memory. It's more work for the printer to like hack through the G code of the sliced outputs. But also at some point it doesn't really matter if you make smaller and smaller meshes because of the resolution of the printers. So what I've found is that usually like a 12-sided, if it's like a 3mm circle, like 24 sides is plenty. That gives segment lengths around or under 0.5 millimeter depending on the hole size. And around, it kind of depends on whether it's an inside or an outside curve, and depends on your printer. And you can experiment, but basically look for the point where for a given radius, and if you don't want segments showing, if you want it to be a smooth curve, there'll sort of be sweet spots where this many arcs will look fairly smooth, it'll be easy on your printer. And it's good. I haven't finished doing it on here, but it's good to throw a little radius on hard corners. That'll help. It'll help reduce ghosting at corners, be easier on your printer. So, if I'm doing a hard corner, and if I want sort of a hard edge design, I might do like a 60 or a 0.6 millimeter offset, and then just do like a little 3 segment arc around that corner, it'll still look like a pretty sharp corner, but you won't get the same ringing because it'll give the printer a little more to process to get the nozzle around that curve. Um, so in SketchUp, probably my biggest pro tip is to work at, don't try working at like the actual millimeter scale for that you'd be printing at. I work at 100 times scale. I work in it's a metric environment with the unit set to millimeters, but everything is 100 times oversized. And then all I do is when I'm ready to print something, I just make a copy of it and I do a scale at 0.01 in all dimensions, and that will get a part that will actually, it'll slice at human size. You can see that my little reference person hanging out here with these, these things that are actually going to output at, that'd be 1.7 centimeters. But the reason to do that is just that SketchUp does have a lower limit on its resolution, and that lower limit is more than enough to basically make it impossible to look at and work with stuff at actual millimeter scale. You just you can see that, like, trying to get close to it, this is actually clipping through my view plane. That's that's really inconvenient if you're actually trying to work on it. So I figured out pretty quick that it was easier to work at large scale and then zoom it in. Yeah, so it's good to know how your part is going to be oriented when you are working on it, even if you're not working on it in printing orientation. It's good to sort of quantize stuff to the layer height you'll be printing at. So I usually quantize to 0.2 millimeters. Like you don't want parts that are some odd value that wouldn't quantize to your layer height, because then kind of depending on what your slicer thinks, you could get it more or less than that value. That's especially important for what I do when I need like a stepped hole. You can see that this has a bunch of weird geometry, but that's actually to make sure that it'll print neatly without a lot of supports if it has to be upside down. So an inside or outside curves don't bridge well. Because you're counting on, you can't have the nozzle's not like connecting point A to point B in a straight line. It's actually trying to trace a curve. That curve's not going to be neat. And so if you do have inside and outside curves, you can get away with a little bit of a shelf. I found this prints pretty neatly, but so I've got these straight lines. So these would be a 0.2 millimeter. A 0.2 millimeter shelf before that outside curve that's just straight face. And then for this hole that needs to be stepped, I have actually skinned it with a 0.2 millimeter skin, and that means that instead of requiring supports for this overhang, it's actually sort of making its own support surface. And that way, so this can print cleanly with no supports, even though it is a stepped hole. And like if you just tried printing it like that, that would not turn out well. But again, so it's important to get that height quantized for skins, so that it's so that's going to be definitely appear as a layer for the slicer, and you don't want it. Most cases, unless you're printing at finer layer resolutions, you don't really want it to be. You don't want it to be more than one layer either. Okay, so that's pretty much all my design, sort of my introductory design thoughts. Realize I haven't done any actual modeling in here. That's but just, I guess, for a quick demonstration, like talking about design rhythms. One thing I didn't like about the original was how curvy it was. It doesn't really match the aesthetic of the rest of my printer. And this part really hasn't been updated for that. So here, I want to take this nice curve edge and I want to make it, a little more squared off with some radii at the ends. So there I've done a an offset there. I'll do a three-sided arc at each corner, and arcs will cut off corners if there's just a corner hanging out. So use the push-pull tool. Extend that down. Of course, this is going to require a fair bit of revision of geometry, but so a common task here. I want this shape to be the same down here. So what I'll do is I'll double-click this, and I'll use the move tool in multiply or copy mode to take a copy down here, and now I know that those because these radii matched before. But now I can quickly copy what I just did there and copy the geometry. And so to finish that off, just get rid of the old. So when you are deleting curves from the bottom like that, you might end up with nasty internal geometry. We'll just clear that out. And this part is going to require supports no matter what, but later on I will probably at least carry those up. So. Okay, looking pretty good. So then I would just need to decide, okay, how much of this do I want to keep? Moving down. I'll decide that later. Clear out my guides because they're a mess. But yeah, I like the way that looks a lot better. I might carry this line out. I find myself a lot thinking in terms of like design rhythms, like how can I repeat shapes and angles in multiple places around a design. So let's say I am ready to print something. So what I will do, see if this is a solid design. It probably is. It is a solid component. Okay, great. So I'll go over to my output zone. I will make a copy like I have before. Use scale. And with SketchUp, you can like move things by hand and then type a value in. So like there, I scaled it a little bit in the uniform direction, but then I typed 0.01 to scale it down to 1%. So now that's selected, I will go to File and Export STL. And so there we go. And then I can fire up Cura. I can see all the ways this won't print very neatly right now. Okay, so there is my part, and we can go to preview and actually sort of check. All right, for example, are the wall thicknesses that I chose going to work with the nozzle size? Yeah, that won't. So I can see there, and this definitely won't print without supports. Not that I was expecting it to. This one's kind of one of those where you can't get away without it. There. So that is how I use SketchUp to design for 3D printing. Yep. Thanks for coming. I'm going to put this up with no editing at all. Ha! Enjoy.